Okay, so I just wanted to add on some information for what you have to do between now and next time I see you. So you have to do the worksheet and the 3 labs. Now, the first lab, the reaction time we covered in class, that's pretty straightforward. The instructions are in the lab sheets there. The only hard part there is that when you get your average time, you have to go to the Google Sheet to enter your data. Make sure that when you do that, you select the tab at the bottom, which represents your class, so that we get the right data in the right places. And so I will then calculate an average once I get enough data in there, and then you can look that up again and use the average to finish off that lab. So that's a pretty short, easy lab. The second lab is measuring the value for G. So that's all going to be through video. So I'll send the link for the YouTube video for that, and you'll be able to collect the data. I also sent you the data set so that you have the ones that are not on the video there. So you have a complete data set for that as well. Okay. The third one is a blend of both from video and take home. So the take home part is going to be you're going to measure the height of the roof line of your house. So that's the part that I wanted to explain to you how you're going to do that and what tools you're going to need to be able to do that. So I'm going to work on the whiteboard here so that I can demo for you and show you what you got to do. So if this is your house, what you're going to do is you are going to go here and you're going to take a tennis ball, uh, racquetball, something, and you're going to throw that ball up and it's going to go up and you want to get it just equal to the roof line there, and then it's going to fall back down. What we're aiming to get is we want to get the time from the highest point here where it's aligned with the roof until it hits the ground. Now, we could use a stopwatch with that, but that's difficult because really you need 3 people doing simultaneous times on one trial to get 3 representative times and average those out, but you're not going to have 4 people working with you here. So we're going to do this with a different method. What we're going to do is the following: is you're going to have an assistant, so somebody in your family is going to be out here, and they're going to take their phone and they're going to videotape it. They're going to record it from the time it goes from the highest point until it reaches the ground. And you want them to do that in slow motion. You want them to record that in slow motion. The hardest part here is getting the ball so that it's aligned with the roof. Okay, you're probably gonna have to do multiple trials until you get a trial where you go, yep, that's the one where it was aligned with the roof. Now, you standing here cannot tell if it's aligned with the roof, because if the ball is right here and it's perfectly aligned with the roof, from your perspective, it looks like it's way above the roof. And if from your perspective, the ball looks like it's perfectly aligned with the roof, it's actually way below the roof. So you can't stand underneath here and get a good perspective on when it's aligned. The person who's going to be able to tell that is the person who's standing way over here, because they're going to have a line that's just barely going to be off angle here. And they'll be able to see, yeah, the ball was really well aligned with the roof. So you're going to throw the ball, they're going to film, and when they film, uh, they're going to capture it and say, yeah, it was a good alignment, or no, it wasn't, let's do it again. Once they have a good video, then you can scroll through the video in slow motion and just look at the timeline, and the timeline on your iPhones will allow you in slow motion to get down to the nearest hundredth of a second. So you'll be able to get highest point to a hundredth of a second when it hits the ground to a hundredth of a second. So you'll be able to get a very accurate time for the amount of time for it to fall. So that allows you to get the calculation pretty straightforward, just using the time. The other method we're going to use is the following. And it's the same as the other parts of the lab, but you don't have the tools that I normally give you in class. I have a device to actually measure angles easily in class, but you don't have access to that. So we're gonna have to improvise and make our own device. So what you're gonna do is you're gonna walk at least 30 feet out, okay? And you need a tape measure because you need to measure the distance out from the edge of the building here. So you're gonna measure at least 30 feet out, okay? And what you're gonna do out there is you're going to stand here And you need to get a sight line from your eyeball to the roof line. And what we need to measure is we need to measure this angle theta. Now again, normally I would give you a device that allows you to do that, but you're going to have to improvise. So the way we're going to improvise is you're going to use your phone. If you have an iPhone, within the iPhone, you have a feature which is labeled as measure. Okay, so if I hold that up there, you're going to see measure. I'm going to open that up. And there are two features. One allows you to measure distances, but it's not particularly accurate. And it also usually only works at close range. The other one we have is angles. And what that allows us to do is to actually measure angles. Now, the first thing you have to do is calibrate your phone. So you need to lay it on a flat surface and make sure that it's giving you 0 degrees, okay? If it's not giving you 0 degrees, then it's not measuring correctly, so you need to adjust there until you get it. So put it on a flat surface and it should read 0, okay? And you'll know it reads 0 because it lights up the screen, lights up green. Let me see if I can get this on camera here. Okay. So you see those two dots, okay? As those move towards each other, if you get them to align perfectly with each other, screen turns green and that tells you it's level, all right? So this is an inclinometer, and what it allows us to do is to measure the angle of inclination. Now it's hard to do that, to measure at a distance without something that's going to make sure that your sight line lines up well with it. So the way you're going to do that is you're going to make your own tool. And what you're going to do is you're going to take 2 full sheets of paper and you're going to put them where they overlap somewhat. And then what you're going to do is you're going to roll that up so it basically becomes like a telescope, right? Or a straw. And you want to make it as small a tube as possible, but that you can still see through. Once you got that, you're going to take your phone and you're going to tape it, okay? So tape it together like that. What you now have is an inclinometer that you can look at, and when you see the thing that you're trying to aim for through the tube, that means you're aligned with it. It's a straight line from your eyeball to the thing you're aiming at, and you need somebody to read the angle off the top. Now what's going to be hard there is if I'm up here, that person's going to have to be really tall to measure the angle. So instead, what we're going to do is drop down to one knee, and now you can measure the angle really well. The thinner the tube is, the more accurate your measurement will be. So don't make a tube that's this big around. That's not going to be very accurate. You want to close it down as much as possible and make a nice straight tube. Just tape it over so it holds together, and that will allow you to measure really accurate angles here using your phone. Okay. Now, we will have to make another adjustment. It asks you to measure the height of your eyeball. Well, if you're kneeling on the ground, that's not going to be this height. That's going to be the height of your eyeball above the ground when you're kneeling down. So you do have to make that adjustment to the data. All right. So make sure that your picture represents that and that the height that you measure is the correct height. All right. So that's going to allow you to calculate out the height of the roof here. Be aware that the value that you calculate is not the height of the roof. The value you're calculating is from your eyeball up. Okay. So you have to make an adjustment here for that additional value to make sure you get the full value there. All right. So that's what we're going to do. I'm going to put all the requirements, what you're supposed to do here in the feed in just a second here. So check that as well. All right. And we'll see you on Monday or Tuesday, depending on which class you're in. Okay.